Hello viewers, Wagadaruna taking you through the story for O-level mathematics, and this video we're going to go through the topic of vectors for senior 2. So this video is suitable for students in both senior 2, senior 3 and senior 4. So before anything, let's just look at the course outline for O-level mathematics. So course outline for O-level mathematics: senior 2 has 12 topics and these are the topics. Senior 3 has 11 topics and these are the ones, and senior 4 has 6 topics and these are the topics. So what is ticked means that it is already available on this platform. So statistics is available, commercial arithmetic for senior 2 is available, and also matrices for senior 3 are available. So if you want any of these videos, just wait. At the end of this video you'll see an end screen which is in this form. So for example, if you want videos for senior 2, this is a folder for senior 2, so you double click on it and it will take you to the videos of the senior 2. And this is a folder for senior 3, so if you want videos for senior 3, you'll double click on this at the end of this video, so it will take you to videos of senior 3. So you start by defining a vector. So a vector is a quantity which has both magnitude and a specific direction. The opposite of a vector is called a scalar, and for it has only magnitude. So a vector is denoted by a single lowercase letter with tilde. Now tilde is this symbol you see here, and this is a lowercase. Lowercase means a small letter. So there are two ways of representing a vector. One is by one single lowercase letter with a tilde below it, or two uppercase letters in order of the direction of the vector, either in bold or with an arrow above them. So I can either write it like this or like this. Any of the two is okay. So a vector from A to B is noted by AB or AB with an arrow. Just as you see on this diagram, we have this vector A denoted by L tilde and this vector AB denoted by AB with an arrow. What about opposite vectors? So a vector in opposite direction to A tilde is denoted by attaching a negative sign on A tilde. So that means that this vector, just as you see it here, is negative A tilde because it is in the opposite direction of vector A. Similarly, a vector in the opposite direction of AB is, i.e. from B to A, is noted by BA, just as you see it here. This was AB, so the one in the opposite direction will be BA. So BA means it starts from B and ends at A, while AB means it starts from A and ends at B. So usually where it starts from, the starting point is usually known as the tail or the initial position, and the end point is usually known as the head or the final position. Now let's go to what we call position vectors. So a position vector is a vector whose initial point is the origin, and it extends from the origin to a point of interest. In general, a vector has no specific location in space and it is called a free vector. Some vectors, however, are constrained to a specific position. For example, an example of such is vector OF. For this one, it means that the starting point is the origin, which is always fixed, and it is 0, 0. So such a vector is called the position vector of A. So each time they ask for the position vector of A, just know that it has to be written in this form, OA. Why? Because we cannot write a vector, we cannot represent a vector with a single uppercase letter. That will not be okay. So if you want it to represent in terms of capital letters, it should be OA as long as it is a position vector. Conventionally, the position vector of OA can be denoted by a single letter, which is lowercase. So I think we realize that this A is lowercase and there is a tilde above it. So in that case, it is okay because a vector, if you want to represent it with a single letter, that letter must be a lowercase and with a tilde below it. So that means that OA is the same as A tilde, OB is the same as B tilde, OC is the same as C tilde, and so on. So there's something here which is very, very vital for you to remember, is that the position vector OP of a point P which has coordinates x, y can be written as a column vector in this form. Most students forget and they put a division sign here. That will not be okay. Here there's nothing, it's just a column vector. Here this one means that the x coordinate and this is the y coordinate. So don't put a division sign there. So with that, we shall go through some of the questions from UNEB. So question 1 came from UNEB 2002 paper 2 question 4 and says, given that OA is 3 3 and vector OB is 2 0, where OA and OB are position vectors of A and B respectively, find the area of the triangle OAB. So here we have to first locate the positions of A and B. Remember, OA is the position vector based starting from the origin. So there we shall need a graph paper. Then we locate the axes, x-axis and y-axis. They have to be labeled. Then we shall put our scale, demarcate values for the x-axis and also for the y-axis. So the values depend on what is given here. If you look at this, the x coordinate it is 3 which is highest, and also y coordinate it is 3 which is highest. That's why it's okay to stop at 3 here and also stop at 3 there. So first we shall locate the position. So point A is 3 3, so you move 3 here and also 3 here to locate that point A. Then point B is 2 0, so it will be here. So now for triangle OAB, we have to locate point O, which is here, which is the origin. And therefore we shall join to form a triangle. We shall join A to B, then B to O is already there, then we shall join O to A. So this is the triangle OAB. Now to get the area, remember area is half base times height, so we shall drop a perpendicular here. Let's first drop that perpendicular, and that would be our height. Then the base will be from here up to here. Therefore we shall come and say that area is equal to half base times height. Now the base is OB, which has 2 units, 1 2. Then the height has, we have 1 2 3, so there are 3 units for the height. Therefore we shall come and substitute for base, which is 2, and height, which is 3. Then can simplify this, and this cancels to remain with 3 square units as the area they wanted. So now we shall go to question 2, which came from UNEB 1990 paper 2 question 9 and says, the position vectors of the vertices of a triangle ABC are OA, which is that, OB, which is that, and OC, which is that. Find the area of triangle. Find the area of the triangle. So still here we shall need our graph paper, so you can show the positions of A, B, and C. So let's first label the axes, draw the axes, and label them, x-axis and y-axis. Then put values on the x-axis with the correct scale. Then also choose a correct scale for the y-axis. Now where to stop depends on the values given. So if you look at the x values, we have 5 as the highest. Then the y values, we have 4 as the highest. That's why here for y we stop at 4, and for x we stop at 5. Now we are going to locate these points. OA, which is 2 0, it will be here. Then OB, which is 5 0, so 5 0, which is here. Then OC, which is 2 4, so 2 you go and reach 4, which is there. So now that you have got A, B, and C, we are going to join. So we shall join C to B, and also now B to A is already joined, so next is to join A to C, and that will be a right angled triangle. Therefore, the area of ABC is equal to half base times height. Now the base is AB and the height is AC. Next is substitute. What is AB? AB has 1, 2, 3. So 3 units, that's why you see 3 there. Then AC has 1, 2, 3, 4. That's why you see 4 there. The next, this can reduce with this to remain with 2, and 2 times 3 gives you 6. So then we shall come up with 6 square units as the area they wanted. So now we shall go to addition and subtraction of vectors. Here we shall see that when adding or subtracting two vectors, we must add or subtract corresponding displacements. Now this word corresponding, which is what it means. It means that horizontal displacements and vertical displacements are added or subtracted differently. Now the displacements are these ones that mean, for example, if this is vector A and this is vector B, the horizontal displacement is the one which is up. Then the one which is below is the vertical displacements. Therefore, when I'm adding A to B, vector A to vector B, it means that I'll have to first add this and this to give you this, then add this and this to give you that, and that will be the answer they want. Then for subtraction, do the same. This minus this gives you that, and this minus this gives you that. So that is what we need to know about addition and subtraction. The next is scalar multiple of a vector. We shall look at worked examples after this. So to find the scalar multiple of a vector, we simply multiply each of its components by a scalar. For example, if I have this vector and I want to multiply it by this, and I multiply by this, it means that this scale will multiply with this, and also this scale will multiply with that. And then we shall come up with Ka1, then yet with this gives you Ka2. So now that we have seen addition and subtraction and also scalar multiple of a vector, we can go through these questions. So question 1 says, given vector A which is negative 1, 2, and vector B which is for negative 5, determine the values of A plus B, A minus B, 4A plus 3B, negative 3A minus 2B. So let's start with Roman 1. Roman 1, it is A plus B. So it means that I come and substitute for A and also substitute for B. Then follow the rule, the horizontal displacements alone, this plus this gives you that, vertical displacements alone, this plus this gives you that. So in the end, I simplify this to give you this, and simplify this to give you that, and that will be the answer. Then Roman 2, they want subtraction. So what changes is this here it was addition, here it will be subtraction. Therefore, we shall come up with this minus this to give you this, and this minus this to give you that. Then simplifying this gives you that, and simplifying this gives you that. And that will be the answer. So now we shall go to Roman 3, where they want 4A plus 3B. So in this case, 4 is a scalar and also 3 is a scalar. Therefore, this 4 will multiply with this and also with this, and this 3 will multiply with this and also with this. So let's start with the horizontal displacements. So it will be this times this to give you negative 4, which is here, then plus this times this, which will to give you 12, which is here. When I add, I'll come up with 8. That is horizontal. What about vertical? Vertical, this times this gives you 8, which is here. This times this gives you negative 15, which is here. Now plus and minus gives you negative, that's why you see negative there. So in the end, this gives you negative 7, and that will be the vector they wanted. The Roman 4, it has negatives, so we have negative 3A minus 2B. So still this negative 3 is a scalar, and also this negative 2 is a scalar. Therefore, this times this gives you this times this gives you that, and this subtraction is here. So in the end, you come up with negative 5. Then this times this gives you this, and this times this gives you this. Now it is a positive because this times this gives you negative 10, and also here there's a negative, so negative and negative gives you a positive. Then simplify this to give you that, simplify this to give you that, and that's what they wanted. So now we shall go to question 2, which came from UNEB 2011 paper 2 question 9, and says, given that S has coordinates -2, 6, and T has coordinates 3, 3, are 2 points, find the coordinates of R if OR is equal to 4OS plus a third OT. So we are given the values, the coordinates of S and T, meaning that we can be able to get the position vectors OS and OT. So OS is this in column form and OT is this in column form. This 4 is maintained and this third is maintained. Now this multiplies with this gives you -8, and this with this gives you 24. Then this time this gives you 1, and this time this gives you 1. Then when I add this plus this gives you -7, this plus this gives you positive 25. Therefore the coordinates of R are -7, 25. So now we shall go to vector diagrams for addition and subtraction. Now suppose that vector diagrams of displacement vectors A tilde and B tilde are as shown below. So A tilde is in this direction, meaning that negative A will be in the opposite direction. B tilde is in this direction, meaning that negative B will be in that direction. Therefore, if C is equal to the sum, which is A plus B, the vector diagram for C is good by first drawing A tilde followed by B tilde as shown. So what they mean is that you'll come and, if I want to draw this, it means that I'll first draw A. So come and take the whole of this as it is and put it here. Then where it stops, remember it started from here and it has stopped here. Now where it stops is where you add on what is given here. So that is B tilde, meaning that you're going to take the whole of this and put it there. So it starts from here and ends here. So the overall starting point and the overall end point, the line joining the two, will be the vector of C. That was for addition. What if it was subtraction? So if C is equal to A minus B, the vector diagram of C is got by first drawing vector A followed by negative vector B as shown. Why? Because A minus B is the same as A plus negative B. Therefore I'm going to first draw A as you see it here, then from there followed by negative B. So negative B is here, which is there. So now remember the overall starting point was this and the end point is this. Therefore a line joining those 2 points will be our vector C, which as you can see it here. So basically that is how we can draw vector diagrams for addition and subtraction. Now with that, let's go through some of the questions. Question 1 came from UNEB 1989, paper 2, question 13, and says, express as a single vector y tilde plus b tilde from this diagram. So if you look at y tilde is from here up to here, then b tilde is from here up to here. So the starting point is this and the end point is this. Therefore the line joining the two denotes the sum of these two, therefore which will be C. So we shall come here and say that for Roman 1 this addition is negative C. Now why is it negative C? It is because I'm starting from here and I'm moving in this direction. But remember we are given that C is moving in the opposite direction, or it is moving to the left. Therefore if I want the direction to the right, it has to be negative of this. So Roman 2 they said B plus C plus Z. So B is from here up to here, then C is from here up to here, and Z is from here up to here. So the overall starting point is this and end point is that, which is in this direction. Therefore the whole of this will be equal to negative A, because A was moving the opposite direction. They want this direction but the A is in this direction, therefore this must be negative of that. Then question 2 came from UNEB 1988, paper 2, question 5, and says express A plus B plus C plus D as a single vector. That is, A from here up to here, B is from here up to here, and C is from here up to here, and D is from here up to here. So there we shall come and see that first of all, A plus B can be paired together, then C plus D can be paired together. And this is the same as this because it's addition. C plus D is the same as D plus C. Now A is from here up to here, then B is from here up to here. That means that the starting point is this, end point is this, therefore the vector will be vector E. That is why this has been replaced with E. What about D plus C? So from here to here plus from here to here gives you also E. That's why you see another E here. So when you add the two, you'll come up with 2E tilde, and that's what they wanted. So now shall go to question 3. Question 3 came from UNEB 2008, paper 2, question 4, and says given the vectors QR, which is this, ST, which is that, and SR, which is that, find the vector QT. So here we shall first draw an illustration to ease the calculation. So we have QR, we have SR, and also we have ST. Now they want QT. QT means that you will move from here up to here, then from here up to here, then from here up to here, as you can see it here. Therefore, come and substitute for QR. So QR, okay, QR we know it, but RS, you realize that here we have SR and here I have RS. It means that RS will be negative of SR. So once we know that, we shall go ahead and substitute. Therefore, it becomes QR minus SR plus ST. Therefore, QR is this, SR is this, and ST is that. So when I add the horizontal displacements, I'll come up with 7. Vertical displacements, I'll come up with 7. And that's what they wanted. Then question 4 came from UNEB 1991, paper 1, question 15, says a spider made the following 4 moves. OA, which is that, AB, which is that, BC, which is that, and CD, which is that. What single vector is equivalent to the 4 movements? So there we shall need an illustration to ease the calculation. So we have OA, we have AB, we have BC, and we have CD. Therefore, the single vector is vector OD, and it will be got by adding all these ones. So OA plus AB plus BC plus CD, as you can see it here. So come and substitute for OA, for AB, for BC, and for CD. In the end, I'll come up with this as the required vector. So now shall go to displacement vectors. So here we shall come and say that these are vectors which represent motion with respect to a fixed point. For example, vector AB is the displacement vector which represents motion from point A up to point B. So in this case, point A is the fixed point or starting point. So on the other hand, vector BA also denotes displacement vector which represents motion from B up to A. And in this case, point B will be the fixed point or starting point. So we shall consider triangle OAB as shown below. So you need a triangle and label it OAB. So here we have vectors OA and also vector AB. So in this case, I can get vector AB, or I can also get vector BA depending on what I want to be the starting point. So let's look at both cases. So from the vector diagram above, motion A to B is given by AO plus OB. So let's first see where it comes from. So if I want to move from A to B, it means that I'll move from A to O followed by O to B. Now A to O, you will realize that it is in the opposite direction of this. Therefore AO will be negative of OA. So you're coming and say that since AO and OA are directly opposite to each other, then AO is equal to negative OA. Just as I've told you, therefore you come and substitute to come up with this, then rearrange to come up with this. Therefore this gives you the general format for getting displacement vector AB. So if I want to get displacement vector AB, you don't need to go through all these steps. What you need to remember is that the final position vector is what you start with minus the initial position vector. That means that if I want to motion from B to A, it implies that BA will be BO plus OA. But BO and OA and OB are opposite to each other, therefore BO is negative OB. So I'll come and substitute and rearrange to come up with this. Therefore I'll come up with a general format that BA is equal to position vector of the final position minus the position vector of the initial position or starting point. So always remember that for displacement vectors, if I want this, you always begin with the final point minus the starting point, just as it is here, final point minus starting point. That is what you should remember. So with that knowledge, let's go through some of the questions so that you can grasp this concept. So question 1 came from UNEB 1988, paper 2, question 14, and says the position vectors A and B are this and this respectively. So respectively means that for vector A is this and for vector B is that. Find displacement vector AB. So the one vector AB, so shall come and remember that vector AB, this is the final position minus initial position. Therefore come and substitute for OB and OA. Then from there we shall subtract. Subtracting, it will be this minus this to give you this, and this minus this to give you that. And that's what they wanted. Then question 2 came from UNEB 1992, paper 2, question 2, and says if the position vector of point A is this and BA, vector BA is this, find the position vector of B. So here they have done it like in a reverse way. They have given us BA and OA and they want you to get OB. So you shall come in and remember that BA is the same as OA minus OB. Then I'll come and substitute for OA here. But my aim is to make OB the subject. So what I'm going to do, I'm going to take OB this side to become this and take this one this side to become that. Therefore OB will be equal to that. So this minus this gives you negative that, and this minus this gives you 0. And that is what they wanted. Then question 3 came from UNEB 2001, paper 1, question 8, and says in a parallelogram OBCA, OA is that, OB is that, where O is the origin. Find Roman 1 vector BC and Roman 2 the coordinates of C. So in this case we shall need a sketch diagram. So we shall label them in the same order as it was given. O is here, followed by B, followed by C, followed by A. So you don't interchange the order. so must label in that direction. Then for a parallelogram, these sides are parallel and equal, and also these two sides are parallel and equal. What does that mean? It means that BC is equal to OA, and we are given that OA is this, therefore BC is also equal to 4,1. And that's what they wanted in Roman 1. Now Roman 2, they want coordinates of C. So OC from here to here is the same as from here to here plus from here to here. Therefore OB we are given it, and BC we have got it as this. Therefore when I add the two, I'll come up with this 5, 4 as the position vector of C. But remember, they asked for coordinates, therefore we have to write in coordinate form as this, and that will be the answer they wanted. Then question 4 came from UNEB 1990, paper 1, question 21a, and says, given the vectors PQ, which is that, QR, which is that, and the point Q, which is that, find PR. So here we know that PR is equal to PQ plus QR. Therefore PQ is this and QR is that. So add the two, you'll come up with this as the vector of 4 PR. Then Roman 2, they want coordinates of P. So we know that PQ is equal to OQ minus OP. Therefore when I substitute for PQ and also for OQ, I remain with OP as the only unknown, so I have to make OP the subject. What I'm going to do, I'll take this one this side and bring this one this side to come up with this line. So when I subtract these two, I'll come up with this as the position vector of P. But remember, they want coordinates, so we shall write in coordinate form as that, and that's what they wanted. Then question 5 came from UNEB 2019, paper 2, question 11b, and says 2 points M and N have position vectors 3, -1, -2, 5 respectively. So respectively means this is the position vector of M and this is the position vector of N. If P is the point such that 3MN is equal to MP, find the coordinates of P. So there we shall first get this displacement MN. MN is equal to ON. Remember, this is the final, so it will be final minus initial. Then I substitute position vector for N, position vector for M, subtract the two to come up with this. But we are given in the question that 3MN is equal to MP. Therefore, come and substitute for MN. There's a 3 here maintained. Then MP, remember that is equal to final minus initial. And the good thing, I also have the vector for M. So I come and substitute there. So I remain with OP as the only unknown. So what I'm going to do, I'll take this one this side to come up with this. And when I add these, I'll come up with this. But they want the answer in coordinate form, so coordinate of P will be that. So now we shall go to magnitude of a vector. So magnitude of a vector is the size, length, or modulus of a vector. So all these three terms can be used. They can say find the magnitude of vector this, or find the size of vector this, or find the length of the vector this, or find the modulus of vector this. So all these four words, they mean the same. So the magnitude of a vector is noted by the symbol this. So when you see these two bars, just vertical, just know that it means magnitude. Therefore the symbol this denotes magnitude of vector A. That means that if I have vector A as this, it implies the magnitude will be given by the formula that square root of x squared plus y squared. So always remember that this is the formula for magnitude of a vector. This component, you square it, put it here, get this one, square it, put it here, add the 2 and put them under square root. So there is something we need to note, is that a vector whose magnitude is 0 is known as a zero vector or a null vector. Also, a vector whose magnitude is 1 is known as a unit vector. Now with that knowledge, let's go through a number of questions so that you can easily grasp the concept. So question 1 came from UNEB 2019 paper 2 question 8 and says, given vector A, this and B is equal to 3A, find magnitude of A plus B. So like I said, these vertical bars mean magnitude, so the one magnitude of A plus B. Now we are given A but we don't know B, so what we are going to do, we shall first use the given formula to get the value of B. So this by this gives you this, and this by this gives you that. Now that I've got B and I know A, I can come and get A plus B. So A plus B is equal to this, so I'll get this A and add it to this B, so this plus this gives you that, and this plus this gives you that. Now that I've got A plus B, I can now get the magnitude. Remember magnitude, we said get this one, square it, put it here, and get this one also, square it, put it here, everything under square root. So when I get the whole of, so the whole of this will give me this. And when I use the calculator, I'll come up with this to 2 decimal places. So in Olevel we use 2 decimal places. Then question 2 came from UNEB 2017 paper 2 question 15a and says, if A, vector A is that, vector B is that, vector C is that, and this, the whole of this is equal to vector C, find vector M and Roman 2 magnitude of M. So we are going to first quote this which is given, then we shall substitute for A, B and C. After which we shall say this one multiplied by through the whole of this will give you this. But remember, my aim is to make this one the subject. So what I'm going to do, this plus this gives you this -9, this plus this gives you this +9. Then I have to take the whole of this side to come up with that. Then subtract this minus this gives you this minus this gives you that. Now that is the vector, but they also want the magnitude. So magnitude means get this one, square it, get this one, square it, everything under root. Then use a calculator and come up with the required value. Now we shall go to question 3. Question 3 came from UNEB 2015 paper 2 question 4 and says, given that P is that, Q is that, are 2 points in a plane, determine part A vector PQ and part B magnitude of PQ. So PQ means that Q is the final, so it will be final minus initial. So substitute for OQ, substitute for OP, subtract the 2 to come up with this. Then Roman 2, they wanted magnitude. So magnitude means get this one, square it, get this one, square it, everything under square root. You will come up with 5.83 to 2 decimal places. For Olevel we use 2 decimal places. Then question 4 came from UNEB 2014 paper 2 question 10 and says, given that Q is that, R is that, are 2 points in the plane, determine vector RQ and magnitude of RQ. So still we shall go through the same procedure. RQ is OQ minus OR. So OQ is that, OR is that. Subtract the 2 to come up with this. Then for the magnitude, you shall come say this squared plus this squared, everything under root to come up with 5 units. Then question 5 came from UNEB 2013 paper 2 question 3 and says, the position vectors of P and Q are this and this respectively. Respectively means this is for P and this is for Q. Find the magnitude of PQ. So the first thing to do is to get vector PQ by saying OQ minus OP. Subtract to come up with this. Then now we can get the magnitude. and to be 14.14 units. Then question 6 came from UNEB 2010 paper 2 question 7 and says, given that vector A is that, vector B is that, and M is that, find the magnitude of M. So for you to get the magnitude of M, you have to first get vector M. So M is given by this formula from the question, so I'll substitute for A and for B. Then I do perform a scalar multiplication on this to come up with that. Then add these two to come up with this. So that is the vector, but remember they want magnitude. So magnitude would be this squared plus this squared, everything under square root to come up with 13 units. Then question 7 came from UNEB 2009 paper 1 question 16a and says, given the vectors A which is that, B which is that, and C which is that, find part A plus 2B plus C, and part B, length of A plus 2B plus C. So the good thing, we have vectors A, B and C, so we shall come and substitute for A, B and C. Then here this scalar multiplication will give you this. Then when I add this plus this plus this, come up with this. Then this plus this plus this, come up with this. So that is Roman 1. Roman 2, they wanted length. Length is the same as magnitude. So magnitude of that will give you this squared, which is here. Then this squared, put it here, everything under root to come up with 30 units. Now we shall go to question 8, which came from UNEB 2007, paper 1, question 13b, and says, points A and B have coordinates 0, -1, -6, 7. respectively. So respectively means A is this and B is that. Find vector AB and Roman 2 magnitude of AB. So vector AB will be equal to OB minus OA. Substitute OB, OA to come up with this. But they want also magnitude, so magnitude will be this squared plus this squared, everything under square root to come up with 10 units. Then question 9 came from UNEB 2000 paper 1 question 7 and says, given the points L and M, find vector LM and length of LM. So LM is equal to OM minus OL, so substitute for OM, substitute for OL, subtract to come up with this. Then length means magnitude, so magnitude means this squared plus this squared, everything under square root to come up with 5 units. Then question 10 came from UNEB 1992 paper 2 question 10 and says, an insect moves along straight lines from point A, which is that, to point B, which is that, and finally to point C, which is that. How far is the insect from its starting point? So you come and say that displacement vector will be FC because that's from A and ends at C. Now SC is equal to from A to B because they said it moved from A to B and finally to C. So it will be A to B then plus B to C. But you already know that AB is the same as OB minus OA and BC is the same as OC minus OA. Therefore, I'll come and substitute for OB and OA, then OC and OB. Then from there, this gives you this and this gives you this. And when I add these two, I'll come up with this, which is the displacement. But remember, they said how far, meaning that they want the distance, which is the magnitude. Therefore, magnitude will be this squared plus this squared, everything under square root to come up with 5 units. So now we shall go to midpoint of two position vectors. So suppose that OA and OB are position vectors of points A and B respectively. The position vector OC of the midpoint of AB can be got as follows. So if I have 3 points, I have a point A, I have point B, and I have point C, and this point C is the midpoint, means that this distance is equal to this distance. That's why you see here SC is equal to CB. Then SC I already know that's the same as OC minus OA, and this one I already know the same as OB minus OC. Therefore, I'll take this one this side to come up with 2OC, then take this one this side to come up with OA plus OB. But I want to make OC the subject, so I'll divide by 2 to come up with OC being equal to a half in brackets OA plus OB. And this is the formula for getting midpoint of two position vectors. So I'll use that knowledge to go through a number of questions that I can easily grasp the concept. So question 1 came from UNEB 2002 paper 1 question 7 and says 2 points P and Q are in a plane. Find Roman 1 part A the coordinates of M, which is the midpoint of PQ, and part B the magnitude of OM, where O is the origin. So OM will be equal to half of OP plus OQ. Then I come and substitute OP and substitute for OQ. Then the whole of this gives you this. Then scalar multiplication gives you that, and that is OM. But they want it in coordinate form, so you write in coordinate form, and that is part A. Then for part B, they wanted magnitude of OM, so magnitude of this, meaning it will be this squared plus this squared, everything under square root. You come up with 4.61 to decimal places. Then question 2 came from UNEB 1996 paper 1 question 9 and says 3 points OP and Q in the same plane have position vectors that, this and that. Find the coordinates of R, the midpoint of PQ, and the distance of R from O. So the midpoint of PQ will be given by half of OP plus OQ. So substitute for OP, substitute for OQ, simplify this to come up with this, then scalar multiplication to come up with that. Therefore the coordinate is that, but they also wanted distance. Distance means magnitude, so this squared plus this squared, everything under square root to come up with 10 units. So now we shall go to question 3. Question 3 came from UNEB 2008 paper 1 question 14 and says, given that the points A has coordinates this and vector AB is this, and M is the midpoint of AB, part A, find Roman 1 column vector of column vector AM. Now we have AB and we have coordinates of A, but we don't have this vector of M, position vector of M. Therefore we have to first look for that M. So we shall come and say that if I have A, if this is A and this is B and this is M, they want AM from here to here, but remember from here to here and from here to here the same. Therefore AM will be a half of AB, and the good thing I have AB, therefore I come as that AM is a half of AB, and AB was given, therefore scalar multiplication gives you that. That was Roman 1. Roman 2, they wanted coordinates of M, so they want OM. So AM is equal to OM minus OA. It's called come and substitute for AM, and for OA remain with OM as the only unknown. Take this one this side to come up with that. Then add these two to come up with OM as that. Therefore the coordinates are these. So now shall go to Roman 3. Roman 3, they want magnitude of OM. So magnitude will be this squared plus this squared, everything under square root. Then you'll come up with these two decimal places as the required answer. So that was part A. Now we shall go to part B. Part B says Roman 1, draw the vector AB on a graph paper. So remember, we have AB and we have the starting point, which is this. So we shall come here and get our graph paper. Then draw the axes and label them, x-axis and y-axis. Then put the scale on the horizontal axis. Then also do the same for the vertical axis. Okay, so now we shall locate point A, because we were told that point A is -8, 6, and that will be point A. Then we also know that vector AB is 12, 4. Now 12 is horizontal and 4 is vertical. So from here, I'm going to move horizontally 12 steps. So when I do that, I'll come up with this. So 12, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 steps horizontally. Then 4 steps vertical. Therefore, I'll move 4 steps upwards. So 1, 2, 3, 4. Now that means that this will be our final point, and that will be point B. Therefore, a line joining A to B is our vector AB. So I'll come and draw a line, and that will be the vector AB they wanted you to represent. Then Roman 2, aside from your graph, state the coordinates of B. So coordinates of B, this is 4 and this is 10. Therefore, the coordinates will be 4, 10. And now we shall go to equality of vectors. So here what you need to know is that two vectors are equal if they have the same magnitude and direction. So suppose vector A is this and vector B is this, and they are equal. That means that if they are equal, this is equal to this and this is equal to that. That is the only concept on this we need to know under this part of equality of vectors. And when that is known, we shall go straight to questions. Question 1 came from UNEB 2012, paper 2, question 4, and says, given the vectors A, which is that, B, which is that, and C, which is that, find the values of the constants P and Q such that C is equal to PA plus PB. Sorry, PA plus QB. So we are going to first quote this as it was given. Then we substitute for vectors A, B, and C. So vector C, put it there. Vector B, put it here. And vector A, put it there. Then from there we shall do scalar multiplication. This times this and this times this to give you this. Then this times this and this times this to give you this. Then from there we shall add. So this plus this gives you this, and this plus this gives you that. Now from there we shall equate. So by equality of vectors, this is equal to this. Therefore P is that. Also, this is equal to this. But the good thing I already know P, so I'll come and substitute for P and look for a way of making Q the subject, and Q will be equal to 3. So that's what they wanted. Then question 2 came from UNEB 1996, paper 2, question 9, and says, if vector U is that, vector V is that, vector W is that, find the values of A and B such that this is equal to that. So the first thing to do is to write the expression given, then you substitute the vectors u, v and w. Then do scalar multiplication, this gives you that and this gives you that. Then from there you add these two to come up with that. Now from there you use the concept of equality. So by equality, it implies that this is equal to this, that is equation 1, then also this is equal to this, and that is equation 2. So you have two equations and two unknowns, so you shall solve simultaneously. I'll say 2 times equation 1 plus equation 2, that will give me this. So when I add this cancel, so here I'll come up with this and here I'll come up with that. That means that b is equal to positive 2. Now that I've got b, I can go in equation 1 and substitute for b, then make a the subject, and a will be 5/2. So that is what they wanted. So now shall go to question 3, which came from UNEB 1990 paper 2 question 11, and says, given that a is that, vector b is that, find the number x and y such that this is equal to that. So the first thing to do is to quote what was given, this as it is. Then you substitute for vector a and b. Then do scalar multiplication, this gives that and this gives you that. Then add the two vectors to come up with that. Then use the concept of equality. So by equality, this is equal to this, that is equation 1. Also this is equal to this, you can reduce it to give you that, and that will be equation 2. So you have to solve them simultaneously. Equation 2 minus 2 times equation 1, I'll come up with that. So this is equation 2, and this 2 times this gives you that. So when I subtract the 2, I'll come up with this, and make y the subject, y will be equal to 2. Now from equation 1, come and substitute for y, and then make x the subject, and that will be the answer. So now I shall go to question 4, which came from UNEB 1987 paper 2 question 3, and says, given that a is that, vector b is that, vector c is that, find the scalars p and q so that this is that. So quote what is given, then you substitute. So here there is a p which was missing, so add it there. Then substitute for a and b and c. Then do scalar multiplication. Then add these two vectors, come up with this. Then use the concept of equality. So by equality, this is equal to that, and also this is equal to that. Now those are two equations and two unknowns. So equation 1 minus 3 times equation 2, I'll come up with that. Therefore q is equal to 1. Then from equation 2, I'll substitute for q and be able to get the value of p. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on vectors for senior 3. So this video has been on vectors for senior 2, and the next video will be on vectors for senior 3. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on vectors for senior 3 has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.